Hi, my name is Bahadur Akhmedov. In this video lecture, we are going to discuss the product rule of differentiation. Essentially, we need to figure out the derivative of the product of the two functions. So sometimes we need to evaluate the derivative of the product of the two polynomials. So essentially, it might be x plus 3 in the power of 3 times the x plus 5 in the power of 5. So what we can do is we can expand the first bracket. It's going to be the polynomial of the third power. We can expand the second bracket. It's going to be the polynomial of the fifth power. We can multiply these two brackets and get the polynomial of the eighth power. So we can take the derivative of each of the terms of that polynomial and figure out the derivative of this function. But it's going to be a long solution, which is really long, which is really inconvenient. So it appears it is possible to find the derivative of this function in a much more shorter way using so-called product rule. But sometimes we need to figure out the derivative of the function where we have to multiply the exponential function to the polynomial x in the square, or sometimes we might need to find the derivative of the function where the exponential function times to the trigonometric function. Well, in this case, it is not going to be possible to solve them even in a long way. So we need to figure out some rules in order to find the derivatives of this kind of functions. And the product rule tells us that, hey, if you are given the multiplication of the two functions f of x and the g of x, the derivative of this function is going to be the derivative of the first function times the second function plus the first function times the derivative of the second function. Well, we can write it down, this formula, in a shorter way by just writing down that fg prime is going to be f prime g plus fg prime. So please note that all of these derivatives are with respect to the variable x. And probably the second line, the formula in the second line, it's easier for us to remember. So we are going to do some examples of using these formulas. For example, we're going to take the derivative of all of the three functions. So we're going to consider the first example, the second example, and the third example. So let's start from the first one. So please note, whenever we are multiplying the two polynomials, so x plus 3 in the power of 3, so x plus 5 in the power of 5, you should know what is the derivative of each of them. So let me denote the first one as the f, the second one as the g for the simplicity. Then its derivative is going to be equal to, according to the formula, f prime g plus fg prime. So first of all, we need to figure out what is the derivative of the x plus 3 in the cube. So this should be very similar to the derivative of the x cube. So the derivative of the x cube is going to be 3x in the square, and the derivative of the x plus 3 in the cube is going to be 3 times the x plus 3 in the square. So you might ask me why these two formulas are the same. So it is not possible to answer this question without knowing the chain rule. So we are going to learn the chain rule in our next video lectures. So far, you just need to know that the derivative of the x plus 3 in the cube is going to be taken in a very much similar way as the derivative of the x in the cube simply. So it's going to be 3 times the x plus 3 in this square times the x plus 5 in the power of 5 plus the first function, which is x plus 3 in the cube, times the derivative of the second one. It's going to be 5, x plus 5 in the power of 4. So that's going to be the derivative of this product. So let's do the second example. So in the second example, we need to multiply a polynomial to the exponential function. So in our case, the exponential function, let's say, is going to be f. The polynomial is going to be the g function, let's say, and the derivative of this function, again, is going to be f prime g plus fg prime. So the derivative of the f, e in the power of x, is going to be simply e in the power of x times the g, which is x in the square, plus the first function is e in the power of x times the derivative of the x squared, which is going to be equal to the 2x. So we probably can take out the inner part of x times the x out of the brackets, and what is left inside for the first term is going to be simply x, and what is left inside for the second term is going to be simply 2. So that's going to be the derivative of the inner part of x times the x in the square. Let's do our third example. So we are given the multiplication of the exponential function to the trigonometric function. So in this case, again, we are going to make the notation. So the first one is going to be the f, the second one is going to be the g function, and the derivative of the product of the f to the g is going to be equal to the f prime g plus f g prime. Well, the derivative of the f is going to be simply e to the power of x times the sine of x plus the first function e to the power of x times the derivative of the sine, which is equal to the cosine of x. Well, we can take out the e to the power of x out of the brackets, and what is left inside is going to be simply sine of x plus the cosine of x. So please note that in order to apply the product rule, we should already know the derivatives of each of the functions separately. So this is what is called like a product rule, and it is really important rule for the differentiation, and it helps us, enables us to find the derivatives when the two functions are multiplied. So thank you very much for your attention. I hope that this video was helpful for you.